Hello, this is Thomas Ott from H2O.ai, and welcome to my talk and demo called Automating the Machine Learning Lifecycle using H2O driverless AI. I only have a few short slides before we actually get into the platform demo. So let's go take a look at what we have to offer at H2O. H2O, the H2O platform, is really made up of three main parts. One is something called H2OQ, which is typically geared for business analysts, which allow them to use AI applications or apps. And these apps can do many different things that go beyond just the standard business intelligence type of work. It allows business analysts to actually use AI to make forecasts, visualize data, explore data in a fashion that is beyond the standard business intelligence tools. But for today, we're going to focus on the other two products. One is driverless AI, which is an automated machine learning tool that allows data scientists to quickly build models, evaluate them, compare, contrast, build pipelines, look at machine learning interpretability, and many other different things as a way for them to leverage the short amount of time that we all have working on projects and getting to a scoring pipeline. Now, the last product is H2O Model Ops. In Model Ops, we allow you to do a one-click deployment from driverless AI into putting a model into production. That model can then be monitored, can then be evaluated in real time to see if it's drifting or other problems exist, thereby allowing the data scientist and the DevOps engineer to work hand in hand and build models and put them into production quickly. Things such as one-click deployment, REST endpoints, scaling on Kubernetes. This is a seamless end-to-end insight to deployment story, which I'll be sharing with you in a few minutes. So let's get to that platform demo now. I'm going to pause for a second, and I'm going to switch to another screen which has my environment running. So hang on tight. We'll be right back. Okay, welcome back. What you see before you here is a launch page for the H2O.ai Platform Studio. We have a couple of products in here. For one, if you remember from my slides before, we have the Q product. You can launch it from here. We have driverless AI, which we'll be focusing on here for the most of the demo. And we have MLOps as well too, which we will also focus on. But I just wanted to give all the data scientists, all the Hadoop administrators out there, just a quick shout out here. We do have two open source libraries called H2O3 and Sparkling Water. Those are predominantly used for large scalable data computation on Hadoop clusters. Very powerful. You can run several distributed algorithms completely on a Hadoop cluster and leverage the memory and the power of, say, a Spark cluster as well too. So if you are tantalized by this demo and want to come find out more information about the other products here, you can check out docs.h2o.ai and navigate to where it says H2O3 or Sparkling Water. But now let's actually concentrate on driverless, and we'll talk about that before we talk about putting a model into production. So let's launch it. It's very GUI driven, so you can do a lot of work directly in the GUI through your favorite browser, whether Chrome or Firefox. But I should also let you know that if you are more of the coding type, you can definitely use our Python or our R client, and you can then use your favorite IDE to interact with driverless in a programmatic way. In fact, a lot of our prospects and customers all really like this and use it quite a lot. But for today, we're going to focus completely in the GUI. First, what we're going to do is we're going to look at what we have up here. We have a projects page, data sets, which is what we're in. We have something called Autoviz, experiments, diagnostics, MLI. We have a bunch of different things up over here. But the most important thing to know is we always start with the data. So let's click on this data set. We're going to be using a credit card default data set to kind of show you how you would build models rather quickly and try different permutations of that model. So let's click on that data set. We're going to go to details. We're going to do a high-level overview of the data. We have a column called ID, limit balance, education, marriage, age, and so forth. And if I were to scroll all the way to the right, I come to my target column called default next month. This data set actually comes from a Kaggle data set. I believe it's a Taiwanese lending type of data. So what we're going to do is we're going to try to predict whether or not we can find people that are going to default on their next month. So it's either 0, 1, it's a binary classification problem. Now there's a couple of different things here that we could do as well with this data set. We could look at it in a tabular form, which a lot of people like to see as well, very reminiscent of the Excel type of things. Or what we can do is if we want to actually kind of quote unquote hack the data as we want to go along, we can do that on the fly here if we know a little bit of Python. So from there you can actually make tweaks and changes on your data set if it didn't load in the way that you wanted it to load. So you can quickly drop columns, you can make conversions and so forth. So this modify by recipe is actually a very popular option too. We'll talk more about recipes here in just a few minutes. Recipes are a very powerful function and feature of driverless, which allows data scientists to insert their own secret sauce or their competitive advantage for better model predictions. So let's cancel out of this. Now, let's actually go and do something really important with this. We're going to use Autoviz. Autoviz is a visualization function that lets you quickly scan through the entire data set and see if there's any unique interactions. Now this is really important because data scientists will spend time building matplotlib libraries or seaborn charts to see any interesting interactions, and they have to dig through thousands, maybe hundreds and thousands of features to see unique combinations. With Autoviz, it does it all automatically. And it's really there to help the data scientist pause for a moment and think about, I didn't realize that there is maybe some outliers in the particular data set. Maybe I didn't catch that. Or maybe I need to kind of pause for a moment and maybe reevaluate my problem. So this is a really great feature of driverless that you can definitely use and quickly scan through all your data sets and see some information. Now, let's actually go back to the datasets page. Now we've looked at the details, we've visualized it. Now actually let's go and predict and build a model. It's as simple as clicking on predict. We're going to say nope. We're going to give it a name. We'll say Toronto Big Data. And what we do is we select the target column. Target column, click on it. We're going to scroll down to get default payment next month. And once we do that, driverless goes ahead and actually loads in some settings here. Accuracy, time, interpretability, and scorer. Now these are all important things. We'll touch on this in a minute here. But I just want to kind of bring you up to speed on what's going on up here. This gives us a high-level view of how many rows we have, how many columns. We can drop columns manually, so let's go do that. We'll drop ID because we don't need that. Just note, driverless will automatically pick out the IDs and drop them automatically. However, if you want to have more finer control, you can definitely do that here. So what else we have? A validation data set. By default, driverless will either do split or cross-fold validation, depending on the level of accuracy. But if you have your own specific validation data set, you can add it here. Or if you have a test data set, you can add that here as well too. If you have a date column and you want to transform it into a time series forecasting problem, you would select the time column here. Now pause for a second, and I just want to let you know that by default, driverless will have 3 main recipes. One is a standard classification or regression feature engineering recipe. The next one is a time series with feature engineering recipe. And the third one is a NLP with feature engineering recipe. Now, if you notice, I said feature engineering for all 3 of them, and that's an important distinction. We have built a very powerful suite of automatic feature engineering that allows data scientists to scan through the space of all possible features and actually use them to find interesting combinations to squeeze out more performance. So, having said that, what about adding your own recipes? Well, this is where driverless becomes very, very unique. If I were to click on expert settings, and for today we're not going to really touch on expert settings with the exception of recipes. Recipes are bits of Python code, Python classes that you can use to build transformers, maybe find a new wonderful way to augment data, let's just say, if we were to look over here, and maybe we were interested in Singapore public holidays. We can build a transformer to automatically extract the date column and append it with the time or the name of the holiday. We could do all that, or if you wanted to, let's just go back a few. If you wanted to go back and say, let's build our own custom loss function or scoring mechanism, we can definitely do that. Let's say, for instance, in binary classes, we were interested in a cost penalization. We can definitely write that as well. It's as simple as importing any different type of libraries as you want, writing a Python class, and quickly then installing it into driverless by just a click of a button. And so we're going to actually do that. Let's go ahead and for today's fun, we're just going to, let's just go back to the transformer. And we will then just select, let's just see, maybe a data augmentation one. Maybe we will see if there's any type of holidays. We were to come over here, click on raw, grab this URL, come back to driverless, load from URL, or if you happen to have it on your hard drive, load it from your directory. Now note, I said transformers and scores. You can also add in your own algorithms as well too. And if you come to our website, you can definitely check out our GitHub repository with over 170 different types of recipes. And they include different algorithms such as Facebook Profit, maybe some clustering, other different types. So definitely come check it out. You click on save and it will automatically load in. And if there is any date columns per se in the actual data set, it will then try to see if it's a Ramadan holiday. In this particular case, we don't have dates, but this was just shown as an example. So you could definitely experiment with it. So now let's just talk about what these 5, 4, 6 AUC means here. Accuracy. The higher the number, and they go from 1 to 10, the more powerful model building techniques driverless will use. I mentioned split validation and cross-fold validation before. Well, what will happen is at a very low accuracy, driverless will say, hey, you're penalizing, you want to penalize accuracy over maybe speed. So we'll use something like maybe split validation. In this case, a quarter validation split, to quickly build models at the expense of a little bit of accuracy. But if I were to crank it maybe say up to 8 or 9, then we're going to say, look, we want to go ahead and use 5-fold cross-validation here and do some more intensive model building to build a more accurate model. So this is something that you should understand when you're playing with accuracy. Accuracy does not mean that for every one value you go up, you get 10 times more accurate power. No. For every value you go up or down, driverless will turn on or turn off different model building techniques. So let's just go back to 5 here, what we had. Now, what about time? Time has to do with that feature engineering part. Remember I had mentioned before about feature engineering in all 3 recipes? Well, this is where the power of driverless really comes in. If, for example, you have a column of house prices and you have a column of square foot area, you could definitely do a simple division and create a column called dollars per square foot. And by doing so, if you built a linear regression model, you may be able to get a better fit model by doing that. But what happens now if you happen to have some demographic data, or maybe a state or province data? Couldn't you also bucket the dollars per square foot maybe into a unique bucket for the state and create a dollars per square foot per state? Well, that's what driverless would continue to do. It would try different combinations from very simple interactions like multiplication and division to more complex interactions like weight of evidence, and as well as maybe clustering or extraction of various word characters. So the time just means how long do you actually build the features. The lower the time, the quicker the features get built, and maybe they become less complex. Interpretability is about that complexity. Remember dollars per square foot? Dollars per square foot is really easy to understand. It's not complex. So the higher this number, the less complex the features get. The lower the number, the more complex. So this is just something for you to play around with as well, as you want to see if you can squeeze out more performance with very complex features versus maybe some very simple feature selection for the top 20 or something along that line. Now, AUC is blinking here because AUC is the selected metric for optimization, but you can have many different ones like log loss. If this is a regression, type of problem. The regression would have things, regression metrics would be root mean squared error, or they would be MAPE or something along those lines. So you can choose what is recommended or not. So let's click on that. Let's launch experiment. And then we'll watch what driverless is doing here. Driverless is now detecting the column types. It's ingesting the data, and it's going to build a base model that's going to try to become better on. And this base model will probably show up down in here in the lower left, and it'll have some performance metric, in this case, area under the curve. And here we go. Look at this. The very first one has an area under the curve of 0.78, and that started over here. And now driverless will try to build other models to try to make them better. In the center here, it's going to start building features. And these features are going to be those combinations. Sometimes they're going to be original features. Sometimes they're going to be derivatives of the original features. And it will try to build different models, and it'll try different feature combinations to squeeze out more and more area under the curve. Over here on the right, we have our ROC curve, an area under the precision recall curve, some lift charts, some gains, and so forth, as well as KS charts. And if you're running on GPU, you'll actually have it as a you'll see GPU usage here as well too. And you can see here, by coming back, we've already built 11 out of, or now 12 out of 18 parameter and feature tuning models. And we're using models like LightGBM or XGBoost. We use a lot of models that can run on GPUs and CPUs. But if you have your own special algorithm, remember those recipes I talked about? You can plug your own recipe in here, and you could give it a try and see if driverless will actually make it bubble to the top as being the best algorithm out of the bunch. Okay, let me pause here for a second, and I'm going to skip ahead, and I want to show something about machine learning interpretability. One of the other great features of driverless AI is the ability to do machine learning interpretability. For that, we actually have two methodologies, which I like to say top down and bottoms up. The top-down approach is a surrogate model approach, where we use a decision tree or a linear regression to try to approximate the decision boundary. And we use that using K-line, for instance. I could look at this, and this is my overall model. If I were to say, let me actually take a look at it and drill down and build clusters, hence the K in K-line, maybe I can actually get a better fit model over here. Maybe I can actually try to understand what's happening in that particular region. Where for this case, if somebody had a PAVE5 value of 8, it tends to increase their default by 42%. Whereas if it's 6, it tends to decrease it by 22%. So you can quickly drill down here through the surrogate model approach and get approximations of your decision boundary. Very powerful stuff. Perhaps the most powerful and the most exact feature contribution analysis is using Shapley values. So for instance here, we can look at Shapley values of the original data set, and we can see PAY1 is a really most powerful feature here. If we wanted to actually look at the features that we're using transformed variables from that feature engineering, we'd look at transform Shapley. And we could see here there are some differences over here, which makes this also a powerful thing to look at original versus feature engineered ones. Now, having said that, how would you actually say take this model, and let's go back to the experiment we're looking at, and which is about 95% of the way done, how would you actually take something like this and put it into production? Well, that's very, very simple to do. And for that, we have to look at projects. So let's come over to projects. For projects, I have a credit card default project where I actually start adding in different projects here that I've been working on. And I had a credit card deploy one, something called few features. I can see my area under the curve here was 0.7748, 0.7312, and I might, after this experiment is done, I'm going to actually link it over here. Let's see if I can actually link that experiment now. If it's done, come over here, and let's give it a second for it actually to pull together. And there we have it. It completed. So now I can quickly look at these, all three of them, and compare them. And I can make a decision on whether or not I actually want to put one into production. You can see here that a very simple one gave me perhaps the simplest AUC, 0.73. We got 0.781. And the other one I worked on was 0.77. So I think we're going to do the Toronto Big Data one. We'll deploy that one. Let's go do that. Let's come over here, and let's toggle this off. Now I can also do other things too. I can actually select other scoring mechanisms. I can get other different data. I can apply a test data set and so forth. But the neat thing about it is once this is in a project, you see these three guys here? Once this is in a project, now it automatically shows up in MLOps. So now let's go to MLOps. All right, we're at the MLOps login page. So let's go ahead and log in. We enter our username and our password. And we log in and we come to the credit card default projects page. We see here there's a couple other projects here that I have going on, but we're going to focus on the credit card default. And if you remember, that project is the same name. Let's come back to driverless, what we called it in over here. So we had three models, and we're going to deploy Toronto Big Data model here today. So let's come over here. Let's go back to MLOps. Let's come and click on credit card default. We have a couple of options: alerts, deployments, models, events. So events are just essentially a log file that's been going on. Models, if we go over here, these are all the models that we have here. Deployments are currently none. And if we have any alerts set up for checking for drift and things of that nature, they would show up over here. But we'll build those maybe later. Let's go back to actually models. I want to put Toronto Big Data into production. I just come over to click on actions. And I have a choice between putting it into development or production or some other way. We're just going to put it in production here. Click on this. Say yes, we're going to confirm, putting that into production. And that's it. If I come to the deployments page now, you'll see here that it's preparing it, and it's going to actually launch it in a few minutes as it's preparing the Kubernetes pods to put it into, and then spawn it, and off we go. So while that's happening over here, what I'm going to do is I'm going to talk a little bit about what other kind of actions we have over here. Monitoring, and then show sample requests, which is, it spins up a REST API automatically and the endpoint. We're going to click on monitoring, and this uses Grafana. And this monitoring is really the dashboard of the entire project, the entire model here. But you can see here nothing's happening, right? Nothing's being collected, nothing's scoring. And so we're going to simulate for this demo here, just some fake data here. I'm going to come back over here. I'm going to go back to MLOps, and I need to come here and grab my endpoint URL. We're going to copy it. I'm going to come back to that Platform Studio, and I'm going to click on Demo, and we're going to pump some fake credit card scoring data in here. And grab it. Okay, hit paste and submit. Hit OK, and now let's go and navigate back to that dashboard here. We're going to change this to every second to actually see the data points going. And you can see here now, if I scroll down, there's no alerts because we don't have anything set up for alerts. But if I were to come over here and scroll down, I can start seeing here that the scoring latency is pretty low. It seems to be like every few seconds there's another dot coming here, which is something that's being scored. I have no drift or population stability index score yet, but I'm collecting samples. I'm 28 samples now. Oh, 31. It keeps going as more data gets scored over here. And you can see here we have some other graphs here that show a heat map or histogram for all the columns. We have an age scatter plot, heat map, and so forth. And if I scroll all the way down to the bottom, I'll see my target variables. My target variables being default 0, default next month for 0, meaning no default, and default 1, showing that there is a default. In this particular case, we really don't have a lot of defaults, which is a pretty good thing. It means the model's doing its business here. We did a good model, but we have a lot of no defaults, which is great too. So there you have it. There's other things that you could do in this particular dashboard. You can create alert rules if you wanted to. We'll say hit yes, we'll hit save. Say big data, big Toronto data, and hit save. And then from here, you could do different things like check for drift. We could set the parameters, for instance, of age, maybe make sure that nobody is above 80 or below 21 or whatever it is. And then all this stuff will then get captured, and we can see it right here in this nice, beautiful scatter plot as we're going along. So that's as simple as building a model in driverless, putting it in a project, and then deploying it within a few clicks in H2O's MLOps. And with that, I'm going to say thank you very much and have a great day. This is Thomas Ott for H2O signing off. Any questions, please feel free to reach out. Bye now.